can see my slide. I think no problem for my slide. Dah nampak slide saya? Nampak tak? Tak ada jawab. Okay.
Nampak.
Six, design of experiment. Formally this slide was prepared by Dr. Savali Samsudin, and I think we also have the latest slide, but I don't have it. Maybe if I after this I got the latest one, I will also release it in the Google Classroom. So in our objective, in this chapter, our objective is why do we have to learn this chapter is that we need to know how to design and conduct engineering experiment. Okay, using the factors, and we also need to know how to explain the concept of completely randomized design single vector experiment. And after we conduct the experiment, we also need to know how to analyze, perform the analysis of variance. Okay, we have to analyze it from the experiment data, and then we need to know, or we are required to be able to analyze the differences between treatment means by multiple comparison technique. And you also need to perform model adequacy checking with the residual plots. This is the these are the objective of this chapter. And in this chapter we have 5 subchapter. The first is introduction, and followed by completely randomized design single vector experiment, and it will be ended by the residual analysis and model adequacy checking. Today class, I think I'm going just to explain about the introduction and little bit on the completely randomized design single vector experiment. So first of all, what is experiment? We should know what is the meaning of experiments. Okay, experiment doesn't mean that we have to do some mixture of substance, maybe in chemical engineering, or maybe you have to do some experiment on measuring some value from testing activities. Experiment can be anything. Okay, experiment can be anything as long as you conduct exercise and then you obtain data. Data can be in numerical. It also can be not in numerical value. But in engineering, most of the time you are going to look for the numerical data. So experiment need to be conducted, especially in engineering field. One is to characterize the process. Okay, the process, the design, the product, maybe the characterization could be activity to understand maybe the material properties, thermal properties, or maybe the quality of machining and so on, or the behavior of a certain machine during the machining process. And after we do some characterization study, we also can perform the optimization works. Okay. Sometimes we only do experiment. We do experiment only to evaluate the material properties, Okay, to evaluate the product design, whether the product design is optimized or not, or maybe we want to do some development or improvement in process. We also need to conduct experiment, collect data, or maybe we want to evaluate component and system tolerance determination. So all experiments are design experiments. Some are properly designed, some are well designed. Okay, uh, that's why we have to do DOE, design of experiment, so that we will not uh, waste our time, waste our energy, or conducting meaningless activities. So these are the benefit of DOE, design of experiment. First is we can reduce the time to design, develop new product and processes. Second is improve performance of existing process, and also we are able to improve the reliability of and performance of product, and maybe we can improve product and process from the point of robustness, and we at least we can evaluate the material design alternatives, setting component and tolerance. So in many cases, product quality, product characteristics involve many parameters. So it is impossible for us to conduct experiment looking on all the parameters or all the variables uh, available in certain conditions. So we have to select which one is the most relevant or significant parameters, or the most influencing parameters to certain product quality, design, and so on. So uh, for that reason, there are a lot of design in design of experiment. We can categorize it into many. The first one is one factor design. Okay, the first one is one factor design. One factor design is considered for investigation, and the objective is to determine whether the effect of response is significantly different at different factor level. The factors can be qualitative or quantitative. For quality factor, no prediction can be performed outside the test level. On the other hand, the data where the factor is quantitative can be used for both investigation of the effect and for prediction purpose. So in this level, in this one factor design, we only have one factor. We can have the qualitative, we can have the quantitative. The qualitative is something is not in numerical. Okay, maybe we conduct survey on whether on temperature. We are asking for the room temperature. We conduct survey on maybe a group of students is using one lecture room. We asking them is what what is their opinion about the room temperature. Maybe we give them selection uh, cool, hot, or uh, others. Okay, so they can only choose whether it's cool or it's hot. It cannot select other. They cannot select other answers. So we only have three answers there. But when we conduct the quantitative, so maybe we can give them the temperature value, maybe 28, 30, 35, or so and so on. So that is what I mean by it means by the qualitative and quantitative. When we use the quantitative, we have the numerical data, we can plot the data, and we can use the graph for prediction. Okay, but when we conduct experiment in qualitative, there is no numerical data, we cannot do any prediction. So the second one is factorial design. In factorial design, multiple factors are investigated simultaneously during the test. So we have more than one factors, at least we have two factors. And the factors could be qualitative or quantitative. Okay? The objective of this design is to identify the factors that have a significant effect. So maybe we conduct an experiment on the speed of a car. Okay, speed of a car, and the factor can be the diameter of the tires and the thickness of the tires. Okay, we have two factors there. Okay, what is the influence of the diameter and the thickness of the tires to the maximum speed? So we can have two factors there, and we can at the end we can do judgment on the influence of diameters and thickness to the maximum achievable speed of car. So in this factorial design, it also can be divided into three types. One is two-level full factorial design. The second is two-level fractional factorial design and general full factorial design. So in general, most of students are using general full factorial design without knowing that they are using this design. General full factorial design, it is a design which is each factor can have a different number of level. Okay, and the factor can be quantitative, qualitative, or both. So sometimes when we conduct experiment, we have two parameters. Maybe you can three parameters. Okay. For example, let's say if we have three parameters. Okay. Each parameters we have different values. Okay. We have different values. Maybe parameter one we have three different values. Parameter two we have two different values, and parameter three maybe we can have five different values. So in this case, we can call it as general full factorial design. Okay, and another two, which is two-level full factorial design and two-level fractional factorial design. We have to look here in this slide. Two-level full factorial design is the number of levels for each factorial is restricted to two. So maybe if you have factors, each of it, we can select the minimum and the maximum value for each factors. Okay, maybe when you conduct a drilling experiment, okay, the factor is maybe the rotation speed. The second one is the thrust force. Okay, rotation speed we can give as the maximum rotation speed for the tool and the minimum rotation speed for the tool. And the transpose, we can have maximum transpose and minimum transpose. It has two levels and it has two factors. Okay, each factor have two levels. So in this case, we call it as two-level full factorial design. Uh, Two-level fractional factorial design is a design where only fractional of complete factual experiments are run by assuming that certain high-order iterations are negligible. This is where we assume that certain level we can ignore it. Okay, we can skip. So the example is n equal to times by k minus p. The k is number of factors. We could have 3, 4, 5, and the p is the fraction index. Okay, we have 2 minus the k with p, where the 2 is the level. So we can have a number of run by calculating this formula. If not, we are just using this n is equal to uh, times k. And there are also others design. One is responsible design. A responsible design, mostly it used to have the conduct experiment use went away from the optimum using a low order polynomial. Most of the time when we want to do for optimization, sometimes we use this RSM method. Mixture experiment is the method that most of uh, study in material or chemical engineering. Okay, when you conduct experiment on blending material, okay, and want to study the new characteristic of the newly developed material, mixture experiment can be used. So it, it, example is given in these slides. Okay, if you want to optimize the tensile strength of stainless steel, the factors of interest might be the proportion of iron, copper, nickel, and chromium in alloy. So the weight fraction of all difference factors must sum up to 100%. Okay. Or in this case, the factor we have 1, 2, 3, 4. Okay, we have iron, copper, nickel, and chromium. So we can uh, give a different value of iron, copper, nickel, and chromium in our mixture, but the total weights or total percentage need to be same, which is 100%. Okay, maybe iron 20%, copper 20%, nickel 20%, and the rest 40% is chromium. And then you can change it iron to 40%, copper 20%, nickel 20%, and chromium 20%. So the total of it always going to be 100%. So the next one, the fifth one is the Taguchi method. Okay, the Taguchi approach is aimed at minimizing the variation. Okay. In a process improvement, especially in industry, there are a lot of factors involved in determining the process quality, process performance. In actual practice, we cannot do experiment or do improvement involving all of these factors identified. Okay, in certain process, we have to select the most influencing factors. So Taguchi methods can help us to minimize uh, the factors and also the levels, and also we can minimize the final or the total trial of experiment by using the Tapiti method. So the rest of two, which is nested design and split plot design, are others method in the OE. Nested design is used with multi-factors where the level of one factors are similar but not identical for different level of another factors. Okay, it's related but not identical, and not it's similar but not identical. A split plot design is a special case of a fractional treatment structure. Okay, it used when some factors are harder or more expensive to vary from others. Uh, but from this type of design of experiment, in mechanical engineering, most of the time you are going to use the factor design. Most of the cases you are using the two level full factorial design and general full factorial design. In some cases, maybe you can use the two level factorial design, depends on what kind of study you conduct. So So what is factor in experiment in engineering? A factor is an input of process. Okay. For example, normally factors, the value in fact of factors when we want to plot a graph usually is going to be in x-axis. Okay, in horizontal line. That is what we call it as factors. As a parameters, we can call it as input parameters. Okay, and it is controllable, but sometimes it's also uncontrollable. But most of the time, it's controllable and selectable. Okay, it depends on us. The value of factors is depend on us. Okay, which value we want to use, what value we want to use in our experiments. From the factors, we conduct using those factors and certain level, we are going to have the response. The response is the results of experiment. Okay? Maybe we want to, for example, measure the temperature of water in a lake. Okay? Uh, the level might be, we can put it as the depth of uh, the water. Okay? Maybe we can have the depth from the surface certain distance, and then we go further deeper. Maybe we have three levels. Okay, that is factor and level. So the response is might be the first depth temperature, okay, second depth temperature, and third depth temperature. So in this slides, table 1 showing the process capability, okay, based on a factor which is the feed rate. Okay, feed rate is the factor, and also we have here another one is machines. Okay, machine from USA and from Japan. It comparing between the USA and Japan. So all of the value here is these are the responses. Okay, this is D factors, and this one. This is the factor which we call it as numerical. Okay, this is not numerical. So conclusion: using US machine at lowest feed rate will result in max process capability. So from this table, using the USA lowest feed rate, we have the higher value here. That means the uh, maximum process capability. This is what is shown in this table. So once again, about the factor, you can call it as input variable. You can refer to table 2. For example, table 2 is this one. Yeah, this one is table 2. And quantitative is something that we can have it in numerical. Quantitative in table 2, the temperature. Okay, temperature we have value here 10, 20, 30, 40, and also we have time. Okay, time. The time is like here. Run number 1, 2, 3, 4, 5 until 24. And the qualitative, it is not in numerical. Qualitative can be the type of machine, can be which operators using the machine, and so on. They have different category switch. It has different status. Okay. Let's see. It can be on, it can be off. So we have two level for these factors, on and off, on and off. So that's what does it mean by quantitative parameters or input variable and qualitative input variables. So the level, we have the factors, then we have the level. For this example, for example here we have level is, the first one is 10, 20, 30 and 40. So for factors temperature, we have 4 level here. First level is 10, second level is 20, third level is 30, and fourth is 40. So that's what it means by levels. Okay, we have 4 levels there. And the machine, which is the qualitative factors, we have 3 levels. Okay, made in by USA, by UK, and by Japan. Okay, we have here machine, Japan, USA, and UK. So we have 3 levels of quantitative factors. So that's what it means by the quantitative factors levels. Okay, switch is also qualitative, whether it's on or off. We only have 2 levels here. So the next, the run. Okay, a run is one set of labels for all factors in experiment. Okay, in below experiment refer number 2, there are 3 factors. Okay, we have temperature, machine. The total number of run we can calculate it as using this formula. Okay, the first factors number of levels, the second factors number of levels, the third factors number of levels. So all of the levels number the time is, and we can have 24. Okay, 4 times 3 times 2, we have 24. So total in this experiment, we have to conduct 24 experiments. Okay, so when we arrange it in a table before the experiment, we will have total of 24 trials. Okay, trials, sometimes people call it trials in experiment. Many of our lecturer use the words term of trials explaining the run uh, of experiment. Okay, in this statistic subject, we call it as run. But most of the time, lecturer will ask you trial, how many trials. Okay, so for single factor experiment, run is equivalent to level of the factors. The number R of runs is equal to number A of uh, levels. Okay, replicants N is the number of observation at each run. Okay, a larger value of N increase the accuracy of experiment results, but make the experiment more expensive. Uh, for example, we want to conduct an experiment. For example, run 1, we have temperature 10, machine Japan, switch on. Okay, this is the first trial, 24 trial. But then, how many times that we are going to replicate this experiment at this level, okay, at this parameters setting? 10, Japan, on. So that is what we call it as of N. Okay, when we increase the times of experiment using these parameters, so the data that we collect from the experiment will be much more reliable. We can have the maximum and minimum value. We can have the average. So maybe we can use the final data from the average value. So the total combination of parameter here in table 2, we can see 24. But when we want to increase the accuracy of the data, maybe we can conduct experiment on each combination here, maybe for 3 times. When we conduct experiment for 3 times for each combination here, we can have 24 times 3. Okay, so we can have 72 times. Okay, yeah, maybe 72. So that's basic introduction of what do we means by runs, factors, trials. So the next one is the response. The response is the data that we have to collect, or the answer, or the results from experiment. Okay? Response is dependent on the values of the factors. Type of response. We have a larger the better, nominal the best. Okay, so we have many types of response. These two are only for example, larger the better. Maybe if for the product yield, process capability, student marks, okay, student capability, the profit rate. So larger is the better. Smaller the better, maybe the product cost, number of errors, number of rejects, maybe the surface roughness of product, and nominal the best, maybe the diameter of shaft, because we want to have the assembly process. And so from the OE, we can find out which factor have effect on the response and the direction of the influence. So whether it's increasing or decreasing. So we can also do predictions from the plotted graph. Okay. So how we do the prediction? The method is explained in chapter 5, okay, which is linear regression. So this is another example. Okay, example 1.0 single factor a test book A 2 and 3 R is 2. A is uh, factor which is textbooks. Okay, we have two levels, textbook 1 and textbook 2. Okay, from each level we have three uh, trial. Okay, and we have two are there is the response. Okay, we have at final we have average of 37 and 50. This is the uh, final response of this experiment. Example two factors. Okay, one is the textbooks. The second one is study hour. Okay, we have two factors in this experiment. Each factors, okay, having different level. First factors here, the student marks, we have three levels, but another factors which is not it is a quantitative no, it's a qualitative factors. It have two, so we have text 1 and text 2. So each of it we have different n. Okay, okay, we have 2n for each level in factor B. Okay, so we have total data here. We have 1, 2, 3, 4, 5, 6. Okay, we have 12 response. So for factor 1, text A, we have 6 response. Text 2, we have another 6 response. So another objective of conducting experiment using DOE is determining which factor are most influential, determining where to set the influentials, and determining where to set the influential axis. So the variability Y is small or Y is near to the desired requirement. Okay. So this slide 18, I think it already mentioned in the first maybe 5 slides. You can read it again. And the next is about the single factors experiment. Okay. So I think this is the introduction of DOE. A lot of things you have to understand and to memorize the terms used in this chapter. What is factors, what is levels, what is trials, and so on. Example has been given in several pages. For example, so, page 13, okay, and 14. So, example in actual real situation, you can look at slide number 15 and 20. Okay, so Next subchapter, I think I'm going to explain to you at the next class. But before that, please read these slides because I think it's better for you to read it first before I give explanation, and maybe you can ask during the class about the content in these slides. So we have another maybe 70 pages to go. I think I will go. I'm. It's better for me to conduct or to explain it in the next class. Uh, so please download the slides from the Google Classroom. And also, I already released the attendance for this class in the Google Classroom. Please answer the attendance inquiry and read this chapter before I go to the actual presentation explaining about this chapter in further. And also, we are going to have a test 2 in 5 June. Eh? Kita akan ada test kan? Kita akan ada test kita akan ada test 2 di pada 5 hari bulan Pukul berapa saya dihantar itu? Dalam 5, pukul 5, pukul 3 petang berapa. Jadi test itu kalau test pertama in our first test you only have chapter 1 and chapter 2 kan. In this test 2 you are going to have question from chapter 3 and chapter 4. Okay. Chapter 4 about the data plotting data plotting. Maybe we can have a little bit revision next week on chapter 4. Chapter 5 and chapter 6 will be the question you have to answer it in the final exam. Okay, you must answer questions from chapter 5 and chapter 6 in your final examinations. So chapter 5, I think I hope you have already seen my video and already read the slides, and but I think I still need to explain it directly so that you can ask me about certain question or any question that you have in chapter 5. So that's maybe I can do it in next weeks after we have covered maybe half of chapter 6. Okay. Okay, saya rasa hari ni kelas ni baru nak masuk. Kelas kita dah habis. Okay, saya rasa kelas saya sampai setakat ni untuk hari ni.